velocity of end A of rigid rod placed between two smooth vertical walls is u. Okay, so velocity of this end A is u. Find out the velocity of end B of rod. Rod always remains in contact with vertical wall, and also find the velocity of the center of rod. Also find equation of center of rod. Okay, so first we will find velocity. So if this point is moving with velocity v, suppose, okay, this point is moving with velocity capital V. This is moving with speed u. Okay, this is u and this is v. So I have already discussed this kind of question. The component of u we will take along the length of the rod. So if this is theta and this is phi, so what we can do is we can write u cos phi, that is component of u along the rod, that should be equal to v cos theta. So this is theta. So v cos theta, the component of v along the rod, v cos theta, and u, and this is what, cos 90 minus theta, that equal to v cos theta. Okay, so this will be u sin theta equal to v cos theta. Okay, so this is how much? V is u tan theta. So this much we are getting. Okay, so this is the velocity of end B. Now find out the velocity of end B of the rod. Rod always remains in contact. Now we have to find the center of rod velocity. Center of rod. So how do you find center of rod velocity? Okay, so if this is suppose point 0, 0, and this is suppose x, this is x, and this is y. So if this is x, then what will be the center point? Will it be at x by 2? The center, the coordinate of the center, will it be a, the distance is y, so half of this is what, up to here it is y by 2. So we can write x by 2 comma y by 2. That we have to find the speed. Dy by dt, y minus, because u is taken in opposite direction, that's why u is taken in the downward direction and y is on taken plus side, so that's why we have written minus. Now if you want to write speed, then we have to write for center of mass. For center of rod, the r is what, x by 2 I cap and y by 2 j cap. If you take its differentiation, the speed of center, that will be how much? Half dx by dt I cap plus half dy by dt j cap, and dx by dt is how much? Dx by dt is v, so v by 2 I cap, and dy by dt is u, so u by 2 j cap. So this much we are getting. This is the velocity of central point. The central point, we have v by 2 velocity in x direction and u by 2 velocity in minus u by 2 in y direction. So center will move like this, v by 2 in this direction and u by 2 in this direction. Okay, and you can find its speed also, velocity. Okay, this is the velocity. You can find its magnitude also, v square plus u square under root, because these two are perpendicular, so square and by 2, you can do it like this. You have to just find the magnitude part. Okay, so you can write like this. Then we have to find the equation of the center. So how do you find equation of center? So what we will do is we will write the value of x we will have value of x by 2. How do we find equation of center? So we will try to relate these two quantities. Okay, so how do we relate? We will write with time. So we will write like this: x direction velocity is given, y direction is given. So we will write at any time t. At any time t. At any time t. The position x position will be how much? See, if you start initially the rod was perfectly vertical. We will assume that at t equal to 0, rod was vertical. Rod is vertical. Okay. At t equal to 0, rod is vertical. So what will be value of x? What will be value of x? The x value will be the x coordinate. The x coordinate of this particle. Suppose we write this as x dash, because x we have used for this part, on this part distance. So we will write x dash, the capital X we can write the capital X. For this one, this is the capital X comma y. Okay. So capital X will be how much? Will it be v in by 2? This capital X, see, this is speed of this point is v. So at any time the distance will be vt, and vt by. Similarly, for y what can we write is initial position. What initially this point is at position equal to so the center was here. So initial y coordinate was what for center? Was it L by 2? So it was L by 2, and now it is going down with some speed. So it is going down with the speed what? By 2. So you can write minus u by 2 into t. See, this is the initial coordinate of y. This is initial value of y coordinate. This is initial value of y coordinate, and this is the u by 2 is the rate of change of y coordinate. So we can write L by 2 minus u by 2t, and these are the two coordinates. Now we can replace the time. If you replace the time, we will get the relation between y and x. So L by 2 minus u by 2, and t will be equal to how much? T will be equal to 2x by v. So we can write t equal to 2x by v. So we are getting L by 2 minus x u by v, or we can write y plus x u by v equal to L by 2. Okay, so this is the equation of the points, because this is relation between x and y for this point. So this way we'll write the equation.